Alright guys, welcome back. So last time we did not do the lesson 2, right? So constructing exponential models. Derek sent chain letters to his friends and this is the model. So we're gonna build the equation, right? So it has 9 out of 10 gains, alright? For every 3 weeks. So 9, that's the p. P is our function. So p of t, right? P of t. And then initially we have 40 friends. So it's gonna be something like this. So let me open the board. Okay, so 9/10, right? So you have this growth every 3 weeks, and initially you have 40 friends. And don't forget you have the original one, right? So every 3 weeks, so t representing the weeks, right? It's right here. T representing the weeks. But we got to divide by 3 because for exponent, because that is every 3 weeks. So this is a geometric series as well, where you just times the next term and you get the next term, right? So here is our p of t, right? P of t. And that is our model here, okay?
Hi.
Alright, so your model is right here. P of t equals to 40 times 1.9, which is 1 and 9 out of 10, right? That is the same thing, refer to the same thing, and then t divided by 3. Alright, that's our exponent. Because you times every time you want to get to the next term. Okay, so let's try another one. Right here we have carbon 14. Alright, so half of this mass every that many years, right? 5,730 years. The mass of the sample carbon 14 can be modeled by a function m. So we know on the left hand side of a function it's gonna be m of t, right, in years. Okay, so let's model it again. M of t. So initially how many grams do we have? Initially we have 741 grams. So that's our initial. Let's put it here. Times the rate, right? So we're gonna half every this amount of years. Okay, half. So that'll be 0.5. That's our rate. Times our exponent, right? How many years? Years is gonna be at the top, but every, right? Every meaning you got divided. You can translate it direct to, I'm gonna divide it every 5,730 years, right? Okay, so that's, oh, sorry about that. So that's our model. This is our model, and let's see if it is correct. Okay, right here. So 1/2 equals to 0.5. Okay, so we got the right answer. Alright, let's try one more. Okay.
The narwhal population.
So 5.6 for every 2.8 months. Alright. Loses. So we're gonna 1 minus that rate, right? Loses at every 2.8 months. 5.6% every 2.8 months. But initially we have a population of some kind of animals. 89,000, right? 89,000. sorry, keep opening that. Okay, so 89,000 is our initial amount of animals, population of animals, and we don't know our rate yet, so our rate is gonna be 1, right? That's the original 1, right? Minus 5.6, I believe, 5.6%, right? 5.6%, and then that's it. Okay, so we're gonna have this and this, and we're gonna put our exponent over here, so that's gonna be, I believe it's gonna be t months. Okay, the t is gonna be months, but every 2.8 months. All right, so what's our initial here? It's gonna be function n. Okay, n of t on our left hand side of the function. Okay, so we completed it. Let's see if it's correct.
But there you have it. We're done. We have.
Okay, so that's our 1 minus 5.6%, right? And we have our t divided by 2.8, so we got it right. And that's it. So that's our lesson 2 of Unit 7, Exponential Models. So that concludes our lessons here. So we can move on to logarithm. All right.